Assalamu alaikum everyone. How are you all? I hope all of you are doing good. As we strive to deal with COVID-19 pandemic and make the best out of this situation, in order to ensure the best possible learning outcome, we, the team of SM Public Academy Campus 5, is introducing online lectures for our students so that they get connected with education, and when they come back, they are not blank at all. Here we have some prevention for COVID-19, that is there you have to take steps to protect yourself. And what are these steps? You have to avoid the close contact, clean your hand or wash your hand, stay at home, cover cough and sneeze, wear a face mask, clean and disinfect your surrounding. Just make sure your surrounding is clean. So stay at home, stay healthy, and take good care of yourself in this lockdown. Here I have chapter number 1, set lecture number 2. My name is Miss Safia and I am your maths teacher for grade 8. So, here I am going to start the topic types of set. Now subset. First we are going to discuss what is subset. What is subset? For suppose a set A is said to be a subset of set B if every element of A is also an element of B. We use the notation like this: A is the subset of B to show that A is the subset of B. Now what does it mean? Like for suppose if I have a set A, if I have set A and set A is equals to 1, 2 and B is equals to 1, 2 and 3. For suppose if the elements of set A is 1 and 2 and the element of B are 1, 2 and 3. Just look here. All the elements in the set A is present. If all the elements of set A is present in set B, if all the elements of set A is present in set B, then set A is said to be a subset of set B. If every element of set A is also an element of B. And how we are going to write it? A is the subset of B. This is the sign of subset. This is the sign of subset, like this. Okay. Now examples are: null set is a subset of every set. Null set is the subset of every set. And second thing is, every set is a subset of itself. Just because for suppose if I said A is equals to 1, 2 and second set of A is 1 and 2. Okay, so A is the subset of set A, or A is the subset of itself, because all the elements of the set A is present in set A. That's why every set is a subset of itself. Now the second property is, or you can say that subset is further divided into proper subset. Proper subset. Basically, proper subset is the part of subset. Now, if set A is a subset of set B, if A is the subset of set B and A is not equals to B, then we write A is the proper subset of B and say that A is the proper subset of B. For example, here A is equals to 1, 2, 3. 1, 2, 3. And B is equals to 1, 2, 3, 4, 5. 1, 1, 1, 2, 3, 4, 5. Now just check it out. All the members or all the elements of set A is present in set B. But set A is not equals to set B. How? All the elements of set A is present in set B, but in set B there are some extra elements. There are some extra elements rather than 1, 2, 3. There is 4 and 5 as well. So, if a set A is the subset of set B plus, second condition is if A is not equals to B, then we say that A is proper subset of B. A is proper subset of B. Next is, now the next category of the subset is improper subset. Now what is improper subset? If A is the subset of B and B is the subset of A, then set A and B are said to be improper subset of one another. How? First suppose here I have improper subset. First suppose if I write here A is equals to 1 and 2, and I write here one more set B is equals to 1 and 2. Now just check it out, this one. All the elements of set A is present in set B, plus there is no any extra element in B. All the elements of set A is present in set B, and set A is equals to set B. Now in this condition, A is improper subset of B and B is improper subset of A, or if A is the subset of B and B is also the subset of A, then A and B are said to be improper subset of one another. Improper subset of one another. Like for suppose improper subset of 1, 2, 3, 4 is 1, 2, 3, 4. Okay. Then come to the power set. Now what is power set? The set of all the possible subsets of set A is called power set of A. If all the subset, like for suppose if you are going to make a subset of set A, the set of all the possible subset of set A is called power set of A. Power set of A means in power set there all the subsets are there. All the subsets are there in power set, and it is denoted by like this. P, power set of A. Power set of A. So what is power set? The set of all the possible subset of set A is called power set of A. So subset is further divided. First subset is there, okay, then subset is divided into proper subset and improper subset. Proper subset and improper subset, and then we have the power set. Then we have power set, and power set is the set in which all the possible subset of any set is there. Okay. Now coming to the next. Now here we have a question that find subset, power set, proper subset and improper subset of A is equals to 1, 2, 3, 4. Now here we have a subset A is equals to 1, 2, 3, 4, and we have to find out subsets of A, power sets of A, proper subsets of A, and then improper subset of A. So first we are going to find out the subsets. Now for the subset we have a formula that is called 2n. 2n. Now what is n? N is the number of elements present in the set. Number of elements present in the set. Now 2n is equals to 2. Number of elements are 4. So 2, 4. Now here n is equals to 4 because n represents the number of elements. Now how we are going to do it? This is just like 2, 4 times 2, okay? 4 times 2. 2 2s are 4, 4 2s are 8, and then 8 2s are 16. This is how we are going to multiply it, okay? 16. Now here we have total 16 subset. 16 subset of A. Now how we are going to make it? First set is always a null set. First set is always a null set. And then we are going to make a set of single element first. Single element. 1, 2, 3, 4. When this is finished, then we are going to make a double digit. Just check the order. First 1 and 2, 1 and 3, 1 and 4, and then 2 and 3, 2 and 4, 3 and 4, and then we are going to make a triple elements. Set of triple elements. 1, 2, 3, 1, 2, 4, 2, 3, 4, 1, 3, 4, and then the last set is 1, 2, 3, 4. These are the subsets of set A. Okay. Now how we are going to find out the power set? Again we are going to put the formula 2 power n, as 4 elements are there, so 2 power 4. Here n is equals to 4 because n represents number of elements. So number of elements are 4. So here we get our answer 16. So there must be 16 power set or 16 subset of A should be made. So how we are going to make it? These are all the subset, and we are going to enclose this subset into the major bracket. This one. See? And this bracket. Okay, this is called power set, and in power set all the subsets are there. All the subsets are there. Now then we are going to find out the proper subset. Now how we are going to find out the proper subset? First we are going to put the formula 2 power n minus 1. First we are going to find out 2 power 4. So 2 power 4 is 16, and then we are going to subtract 1 here. 16 minus 1 is 15. Now in this we are going to make 15 subset. How many set? 16, 15 subset. Okay, 15 subset. So this is how we are going to make it. Okay. The last set is 1, 2, 3, 4, but we are not going to write that set as we have to make 15 set. If I am going to write here the last set 1, 2, 3, 4, then this is not proper subset. As what is the definition of proper subset? If all the element of set A is present in set B, but set A is not equals to B. It means that there must be some other elements in set B other than the elements in set A. So now improper subset. Improper subset, that is the set itself. Set itself. Now this is 1, 2, as we have set A is equals to 1, 2, 3, 4. So 1, 2, 3, 4 is itself a improper subset of A. So here we are going to find out the subset. We done it. We are going to find out the power set. Done. Proper subset. Done. And improper subset. Okay. The common thing is, you know how to find out the subset. how to find out the subset. If you know how to find out the subset, then it is easy for you to find out the power set as well, and then proper subset, and then improper subset. Next. Now, this is question number 4 in your maths book and exercise number 1.1. Here we have a set S is equals to x such that x is a positive integer. Set S is the set in which all the positive integers are there. Find proper subset of S that are also the subset of A, where A is x such that x is an integer less than 3. Now here in set A we are having integer less than 3. So first, set A is all the positive integers, set S is all the positive integers, and set A is the integer less than 3. So here we have 2, 1, 0, then minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, and then so on. These are all the integers less than 3, and these are the positive integers, all the positive integers. Now, proper subset of S and the subset of A are null set 1, 2, then 1 and 2. Now the proper subset of S is, as in S we have 1, 2, 3, 4, but here we have positive integer that is called 1 and 2. 1 and 2, as we don't have the negative integer in set S. So here the proper subset of S and the subsets of A are first null set, and then 1, then 2, and then 1 and 2. These are the proper subset of S and the subset of A. Okay. Next, question number 5, exercise number 1.1. If A is equals to A, B, C, D, then find two sets B and C that are the subset of A such that B is the proper subset of C. Now, for suppose, here we have to make a condition. Let B is equals to A and C is equals to A, B. Then, now check this one. In this, B is the proper subset of C. B is the proper subset of C. Here, as B is equals to A and C is equals to A and B, element of B is present in set C, but there are some extra element, like here we have B also. So then B is the proper subset of C, and B and C are the subset of A. B is the proper subset of C. B is the proper subset of B is the proper subset of C, as all the elements of B is present in C and B is not equals to C. That's why B is the proper subset of C, and B and C are the subset of A, as here we have B is equals to A and C is equals to A and B, and the A set is A, B, C and D. So B is the subset of A, C is the subset of A. Okay. Now the next one is two sets B and C that are the subset of A such that B is the subset of C. So first we have to make a condition. Now, solution. Now, let B is equals to A and B and C is equals to A, B and D. Now here B is the subset of C, as all the element of B is present in C. Okay, and C is the subset of, and B and C are the subset of A. B and C are the subset of A, as all the element of B is present in the set A and all the element of C is present in set A. Okay, now note, you have to note down one thing. Here you can change the element of the set. As I told you, this is the condition which we are going to apply over here. Okay, we are going to write down the elements by our own. So here you can change the element of the set, means that every student may have different answer. You also have, all of you have the different answer for this, just because for suppose here I write here A and B, maybe some of you write here C and D. So every student may have different answer for that, but you have to prove this condition, like two sets B and C that are the subset of A such that B is the proper subset of C. So you have to make such a condition in which you are able to prove B is the proper subset of C. In this you are going to prove B is the subset of C. Okay, now the next is question number 7. Question number 7. Now the question is there any set which has no proper subset? If yes, specify the set. Is there any set which has no proper subset? If yes, then specify the set. Our answer is yes. Why? Because null set has no proper subset. Just because के null set is an empty set, there is no any element in the null set, so null set has no proper subset. Null set has no proper subset. Then question number 8 is, this is in your book. Okay, find a set which has only one proper subset. Find a set which has only one proper subset. So here let A is equals to A. It has only one proper subset, which is the null set. For suppose here I just put the condition, I just make the condition, that is A is equals to A. Now if I am going to write down the subset of this, A is equals to A, as we have just one element, so we are going to put like this 2 and then n. This should be like this. So we are going to make two subset out of this. Two subset out of this. So the first set is the null set and the second one is A. Second one is A. So null set is the proper subset of this set. Just because in set A there is a null set as well, plus there is an element of A. Here you can write, so here you can write any set which is having only one element. Okay, this is up to you. You can write any set. Just for suppose if I write here A is equals to A, you can take it B is equals to C or D is equals to this and this. Okay, this is up to you, but you have to prove this condition. Find a set which has only one proper subset. Okay, now example for question number 9 is, if n b is equals to 5, then n power set of b is equals to dash. Like in this, n b is equals to 5 means number of elements in set B is 5. Number of elements in set B is 5. Then how many power set you are going to make from set B? If number of elements in set B is 5, then how many power set, or how you are going to make power set of this B? Okay, and how many subset are there for B? So here I have 2n 2 5 as the number of elements are 5 and the final answer will be 32. So the number of the power set of set B is 32. Number of the power set of set B is 32. Okay. Now the example for question number 10. Use the set builder form to give an example of null set. Now you are going to use the set builder form to give an example of null set. Like suppose let A is equals to x such that x are 13 months of a year. This is really not exist as because there are 12 months in a year. Okay, so this is null set. Then A is the null set for suppose x such that x plus 4 is equals to 0 and x belongs to natural number and for natural number. Okay, A is null set. A is null set just because if you are going to change this condition, this will be converted into the negative and natural number are positive integer 1 2 3 4. Okay, here you can give a lot of examples. Here you can give a lot of examples by your own. Just you have to make the set builder form to give an example of null set. You can make it in any way. Okay. Question number 11 is consider the set A W X Y Z. Find the proper subset B of A and then find the proper subset C of B and then find the proper subset of D of C. Here we have A only. So first we have to make proper subset. We have to make the proper subset out of this. Okay, proper subset out of this. For suppose A is equals to W X Y Z. Now if I wanted to make the proper subset from this set, so how can I make it? Let B is equals to W X Y because all the elements of set B is present in set A and check it out, all the elements of set B is present in set A plus there is an extra. Z is an extra, so B is the proper subset of A. Okay, now the second condition is this one is proof proper subset of A, then find the proper subset C of B as this one is B. Now you have to make a proper subset of B from this W X Y. Here I make it let C is equals to X Y as all the element of C is present in B. So C is the proper subset of B. This one is also proof. Now the last one is then find the power subset D of C. Now you have to make another proper subset from C. Another proper subset from C. So here I am going to make it let D is equals to X. Then D is the proper subset of C as the element present in D is also present in C and D is not equals to C just because in C there is one more element. Okay, I hope you understand this. You understand all the examples. So you have to practice all these sums. Thank you so much. Take good care of yourself and we'll meet you in the next lecture inshallah. Up till then, take good care of yourself. Stay safe, stay healthy. Allah Hafiz and Fi Amanillah.